Welcome back. You know what? Let me just give it to you right away. Let's start off with the super secret code. The next part of the super secret code, 4-3. You got me? 4-3. One more time. 4-3. All right. Let's talk about drought. Kind of the, thing we're pretty much, if you don't know, the thing we're pretty much known for here in Arizona. So a drought is defined as an extended period of low precipitation that produces a shortage of water for people, animals, and or plants. Droughts tend to affect more people than any other natural hazard. Not necessarily death, not necessarily money-wise, but there's a number of different ways you can define effect. But these are the most wide-reaching, wide-spreading hazards that present itself to humanity. They can cause water shortages, obviously, power shortages if we're reliant on electricity generated by dams, and agricultural problems. Lack of water means lack of farming. It's kind of hard to define a drought, but to do so, it's defined, the beginning and end is defined on the normal conditions in the area, and is also dependent on population or land use. So more people altering land use can also affect whether we are or are not in a drought. Depending on what governmental agency you ask, again, they could have any number of definitions of what a drought is. For instance, a period of unusually persistent dry weather that persists long enough to cause serious problems such as crop damage and or water supply shortages. At the federal level, at the U.S. government level, a drought designation is automatic for any county, like Maricopa County, when D2, which is a severe drought conditions, exists for 8 weeks in a row. So at the federal level, if you're in a severe drought for 8 weeks in a row, then you are officially in a drought. But each state also has their own drought designation criteria. For example, in Arizona, and I'll just read this to you, a drought is declared in Arizona when, quote, a prolonged period of below average precipitation severe enough to negatively impact the environment and human activities occur, end quote. Yeah, okay, but yeah. Anything else? Well, it's declared over in Arizona when, quote, a series of above average precipitation events, especially during the winter and specifically in the form of snow, are needed. One wet winter is not enough to rehydrate the soil and vegetation, end quote. The reason being is snow and the steady runoff it provides as it melts is often more beneficial than rain, which is often temporary. And so the constant melting of snow goes to constantly feed and recharge streams and groundwater. Rain might happen here, might happen there, soaks in, done. But melting snow, if there's enough snow events, that melting snow in the spring and summer can really provide a good constant stream of water. Because snow functions as a natural reservoir, a place where water is stored. So we can store water on top of mountains in the form of snow when there's less demand for it, and nature gradually releases that water in the form of just melting snow runoff during the spring and early summer when water is in high demand. So where in the U.S. is the most severe drought occurring? As of right now, as of April 7th, 2022, it's probably easier to say where it's not occurring, because if you look at this map, any color you see other than white is a drought. So there are some areas of North America where there's no drought, but for the most part, very much drought everywhere. As you get into some of the reds and maroons, that's extreme and exceptional drought. Looking at Arizona, a lot of orange, severe drought, moderate drought, abnormally dry. Pretty much the whole state is in some level of, drought. And that is pretty much everywhere in the West for the most part. And it wasn't always like this. At the same time, April, a couple of years ago, look at this. This is April in 2020. This is April 2022. Big difference. Big difference. Big difference. Still drought in Arizona, go figure. But look at the rest of the country. Big difference. Huge difference. Again, as of right now in Arizona, here's Maricopa County. Phoenix is right in this area, so we're in this kind of moderate drought area. But everywhere in Arizona, everywhere, every single place is colored one of these shades of colors. Therefore, every single place in Arizona is in a drought. And you can see the red up in the some of the reservation area, which is obviously devastating to the people and land up there, as well as along the Colorado River, where there's a lot of farming and agriculture, devastating there as well. So here is the this is drought. What percentage of the state is in a drought from 2000 to present? So what you're looking, excuse me, what you're looking at on the vertical y-axis, how much of the state is in drought. The different colors indicate different severities. So, for instance, the whole state is in a drought if all the colors reach up here, but then you have to look at the different colors to figure out which categories. But in any case, there's a lot of places where we are always, or I should say where the state is in the drought, the whole thing. So there was actually kind of, in the past 20-some years, there's actually been a few kind of major droughts, so it kind of raises up, lasts for a number of years. Then we were kind of considered, so that's the beginning of 2002, and we kind of came out of it mid-2009, came right back into it towards the end of 2009, towards the beginning of 2019, then we were out of it, then right back into it in the mid-2019 until, well, now. So drought, drought, drought. Small little periods in between, but overall this is known as a mega drought, and that has devastating consequences due to climate change. Probably not coming out of that anytime soon. Let's talk about heat waves. Heat, another thing we have here in Arizona. Another devastating atmospheric event. So this is prolonged periods of extreme heat that are both longer and hotter than normal. Go figure. They can accompany either severe humidity or extreme dryness. Obviously, we're on the latter there, but even in places where it's very humid, it doesn't have to get up to 110 or 115 degrees to be hot. In fact, where I'm from in Cleveland, if the humidity, the amount of moisture in the air is 100%, which during the summertime it often is, even though it's only 85, 90 degrees, but with 100% humidity, it's just unbearable. It is 100% unbearable. It does not feel like 85 or 90 degrees whatsoever, because what you are feeling is not necessarily the air temperature, but you're feeling something called the heat index, which is the body's perception of the air temperature. The air is still 85, 90 degrees, but to the body we feel something a little bit different. And that's because moisture in the air, humidity, acts like a blanket. The more moisture in the air, the more it feels like we're kind of stuffed and confined and just making things feel hotter. And that's the heat index, something we have to look at. Heat waves can be exacerbated by the urban heat island effect, which in essence, that's the reason urban areas can be up to 22 degrees Fahrenheit warmer than the surrounding areas. In the middle of the summer, if you've ever been downtown Phoenix and then kind of gone out anywhere way on the outskirts of the suburbs or out into the desert, it's actually much, much cooler because of this urban heat island effect. More on that in a moment. So heat index. So if you look at this axis, this is humidity, how much moisture is in the air, and this is air temperature. So if you have low temperatures and moderate humidity, you're not really changing too much. But the hotter it gets, even though the humidity is relatively low on the scale, the more it feels different. Or even if it's lower temperatures, the more humidity, the more it feels different. So for instance, like I said, if it's 90 degrees in Cleveland in the summertime, but it's 100% humidity, it feels like it's 132 degrees outside. It feels every bit of that. It's miserable. It's horrible. And people die. In fact, it's in this kind of orangish kind of color band, which heat stroke or sunstroke is highly likely. What about here? Well, here, I mean, as soon as we get lower on the scale in humidity, and this is the reason they talk about Arizona being a dry heat, it can be 120 degrees outside, and it feels like 120 degrees because there's no humidity. There's no moisture in the air making it feel any warmer than it already is. But in a place like Houston, right on the Gulf of Mexico in Texas, so it can get hot, say 100 degrees, and then even if you have 50% humidity, you're jumping up to 118. 65% humidity, 136. These are typical conditions. Typically, you're not going to get be in an area where it's 110 degrees and 100% humidity. It'd probably make it feel like it's 500 degrees. Who knows? But humidity has an effect. In this realm, you have kind of danger areas: sunstroke, muscle cramps, heat exhaustion. In this yet lighter orange, sunstroke, muscle cramps, heat exhaustion possible, and then possible fatigue. So heat index not only relates how the air feels, but also if you're exposing yourself to prolonged activity outside, what could happen, and the dangers of temperature added to humidity. And then touching on the urban heat island effect, again, what you can find in downtown areas is that, let's say this is Phoenix. Probably not with all these trees. But let's say this is Phoenix. Downtown, it could be a little over 92 degrees Fahrenheit. You get out into the suburbs, and it drops down a few degrees, 88, 89 degrees. You get out even further into the rural areas, the deserts in this case, and it drop down to 85 degrees. That's a difference of 7 degrees, just depending on where you're at. So why is that? Why do you think that is? Why is it hotter here than on the outskirts? What's the only difference? What's here that's not out here? Well, the answer is buildings. So the urban heat island effect, where it's warmer downtown and gets cooler the further you get away, is due to the fact that in a lot of downtown areas you have a lot of buildings, you have a lot of asphalt, a lot of roads, a lot of concrete. All that material, as the sun's hitting that all day, heats up and stores that heat, and just making the surrounding areas hotter, just because you have all this material absorbing this heat and re-radiating it out. Whereas out in the rural areas, out in the deserts here, or places where there's grass and trees out in farms, well, you don't have all those buildings retaining and then giving off that heat, or all those roads retaining and giving off heat. So you don't have that kind of extra heat source, so it's much cooler. I tell the story of, I went to a concert one time downtown Phoenix 8 years ago. Walked out of the concert venue, miserable outside. It was midsummer, miserable outside. I drove home, and I live out in Avondale, and so drove out to the suburban residential, and I got out of my vehicle, and it was like a whole different area. It was like, why is it so cool? That's the urban heat island effect. I was downtown. I was surrounded by all those buildings as I came out of the venue. Just the heat from the ground, from the buildings, from the air, from everywhere, just made it seem so much hotter, in which it was so much hotter. That's why if you ever look at the news and it's saying, oh, downtown Phoenix, 110 degrees, Avondale, 105, Scottsdale, 102, that downtown area is always going to be hotter, and that's due to the urban heat island effect. So let's pause here. I know this is a long section on severe weather. Thank you for sticking with it. When we come back, we'll talk about the obvious impacts that all of this severe weather has on society. I'll see you back here in just a second.